You are looking at the only consumer product on Earth with a 95% recycling rate. 100 years ago, that meant a man, a hammer, and a horse-drawn cart. Today, a single machine eats an entire sedan in under 10 seconds, and a robot with cameras for eyes can strip a car faster than any human crew ever could. The last step in this evolution will genuinely surprise you. I'm talking about the automobile, the most recycled product on Earth. Over 25 million tons reclaimed every single year. More than glass, aluminum, and plastic combined. But almost nobody knows how we got here, or what's coming next. Because buried in this 100-year timeline is a secret that changes everything. It begins not in a gleaming factory, but in a muddy backyard in the 1920s. By the time the last Model T rolled off the line in 1927, America had a problem nobody saw coming. 15 million cars had been sold. More vehicles than the rest of the world combined. But when those Fords broke a spring, snapped an axle, or blew a head gasket, there was no system to deal with the carcass. So a new kind of businessman emerged from the mud. The auto wrecker. He worked alone with a wrench and a sledgehammer, his horse dragging dead machines into a fenced-off lot behind the feed store. Every radiator, every carburetor, every scrap of copper wire was pulled by hand. Parts went back on the road. Hulk metal went to the mill. Nothing was wasted because nothing could be. The Depression hit and scrap metal became currency. 100 pounds of iron kept a family fed for a week. By the time World War II demanded every ounce of steel for tanks and ships, the backyard junkyard man had become a patriot, his torch cutting through frames as fast as the draft could haul them away. But the man who pulled those cars apart by hand had reached his limit. And the industry that replaced him would stop at nothing. Not even the thing that happened next. Here's what happened next. By 1960, the man with the hammer was losing money. Wages had nearly tripled since the war, and steel mills were suddenly demanding cleaner scrap, metal without upholstery, without glass, without plastic. Junkyards that had once churned profit were drowning in hulks nobody wanted to touch. Then, in 1965, a salvage yard operator in San Antonio named Alton Newell looked at a mountain of dead cars and asked a dangerous question. What if you didn't take the car apart at all? What if you just fed it whole into a machine that could tear it into tiny pieces in seconds? No wrenches, no torches, no hours of labor. Just noise and iron rain. The industry called it the Newell Shredder. It was an electric hammer mill, a 40-ton beast spinning rows of manganese steel hammers at 1,000 revolutions per minute. A full-size sedan went in one end, and in under a minute, fist-sized chunks of clean steel, aluminum, and copper rained out the other. A single machine could eat 300 cars a day, more than a whole crew of men could strip in a month. Within a decade, the backyard junkyard was dead. In its place stood the mega shredder, a concrete cathedral of noise and money. By 1980, over 1,000 of these machines dotted the nation, each one consuming tens of thousands of aging machines every year. And for the first time, the auto industry could claim something radical. The car had become the most recycled consumer product on the planet. But the shredder had a secret. It didn't recycle everything. For every ton of clean steel that came out, about 500 pounds of non-metallic waste piled up behind the plant. Seat foam, dashboard plastic, shattered glass, rubber hoses, fabric, all ground into a toxic confetti the industry called automotive shredder residue, or ASR. They also called it fluff, and nobody wanted it. By the late 1970s, mountains of this black, plastic-laced waste were piling up across the Midwest, leaching cadmium, lead, and PCBs into the groundwater. The same federal government that had once cheered the shredder now turned on it. The Environmental Protection Agency, armed with the new Resource Conservation and Recovery Act, designated shredder residue as a hazardous waste. The industry that had replaced the man with the sledgehammer was now on the verge of being shut down by the same laws that cleaned up the rest of America. And that is when something shifted. Because the salvage operators did not fight the EPA. They swallowed the cost. They installed filtration systems. They developed new separation tables that sifted copper from rubber, foam from glass. They turned a garbage problem into a materials science challenge, and by the year 2000, the modern car was being stripped, shredded, and sorted with such precision that 95% of its weight no longer touched a landfill. The car that had begun as a mud-strewn wreckage in a Pennsylvania lot had become the poster child for the circular economy. But even at 95%, the last 5% was a stubborn puzzle. The fluff still held plastics too mixed to separate, rare earth metals embedded in motors too small to pick out by hand, wiring harnesses wrapped in a dozen different coatings. And lurking on the horizon was a much bigger threat: the electric car. Its battery alone was a 900-pound chemical time bomb. The shredder that could eat a sedan in 10 seconds would turn an EV into a fireball. The very machine that built the modern recycling empire was suddenly obsolete. And the industry that had replaced the man would now have to replace itself. Not with a bigger hammer, but with something that could think. The electric car was already here, and the shredder, the machine that had devoured Detroit's dead for 4 decades, was suddenly a bomb waiting to go off. A Tesla battery pack holds enough energy to run a house for 2 days. Feed it into a hammer mill spinning at 1,000 RPM and you don't get scrap. You get a lithium fire burning at over 3,000 degrees, filling the air with hydrogen fluoride gas. The old way was over, and for a brief, terrifying moment, the industry looked back toward the man with the wrench, as if the only answer was to dismantle every EV by hand in a hazmat suit. But something else was already moving. Not in a scrapyard, but in a robotics lab on the outskirts of Amsterdam. Engineers there had been training machines to see. Not just video cameras, but pressure sensors and near-infrared scanners fed into neural networks that had spent 10 million hours learning the shape of a car. A robotic arm 5 times the size of a human can now pull up to a vehicle, scan its make and model, and decide in real time where to cut, where to twist, and what to extract first. The catalytic converter comes off in 30 seconds. The wiring harness, a nightmare of copper and plastic, is stripped out whole, not ground into fluff. The battery, the 900-pound ticking heart of the EV, is lifted with surgical precision, discharged safely, and sent off for its own specialized recycling. No fires. No fumes. No guesswork. And here is the number that changes everything. Facilities using these smart sorting systems are reporting material recovery rates 20 to 30% higher than traditional shredding. Not on paper, but in real tons of copper, aluminum, platinum, and rare earth metals that no longer end up in a landfill. Workplace injuries in automated dismantling lines have dropped by 60%. The same job that once killed men with crushing accidents and chemical burns is now monitored by a technician in a clean room with a tablet. The junkyard of the 1920s has become a data center. But the real surprise isn't the robot. It's what the robot is learning. Because this same artificial intelligence is not limited to cars. It is now dismantling industrial washing machines, decommissioned fighter jets, and the blades of wind turbines. It sees a toaster and a pickup truck as the same fundamental problem, a collection of valuable atoms temporarily stuck together in a shape someone has stopped using. For the first time in human history, the global waste stream is no longer a growing mountain. It is a searchable database, and the algorithm is getting faster every quarter. This brings us to the stubborn final question. The one the shredder could not answer for 80 years. What happens to the fluff? The 5% that even the smartest robot cannot yet separate. For decades, it was buried, burned, or dumped in developing nations. But buried in a small pilot plant in Austria is the answer. And the last step in this 100-year journey will genuinely surprise you. The plant is in a town most people have never heard of, about 40 miles south of Vienna. It was built by a chemical engineer named Wolfgang, who spent 30 years working for an oil company before he realized the thing he was burning was more valuable than the thing he was making. He started looking at shredder fluff the way a prospector looks at a riverbed. Not as trash, but as trace elements. He told me that 1 ton of automotive shredder residue contains more carbon than a ton of coal. More hydrocarbons than a barrel of crude. The plastics, the foam, the rubber, the fabric, it is all ancient sunlight locked in polymer chains. The problem had never been the material. The problem was the chemistry of getting it back out. In 2021, Wolfgang's team solved it. They built a reactor that uses a process called catalytic depolymerization. It heats the shredded fluff to just under 900 degrees Fahrenheit in an oxygen-free chamber. No burning, no incineration, no smokestack. The long molecular chains snap apart into their original building blocks. Out the other end comes a light synthetic crude oil, clean enough to refine into diesel or jet fuel. The carbon black that's left gets pressed into pellets and sold back to tire manufacturers. The minerals that don't convert tiny fragments of glass and metal too small for any sorter are vitrified into a glass aggregate used in road construction. For the first time in the history of the automobile, the number on the recycling label is not 95%. It is 100. And the one person who proved it possible was not an environmentalist. He was a refinery manager who finally asked what the fluff was actually made of. The plant now runs 24 hours a day, fed by the leftovers from a dozen shredder yards across Central Europe. It produces 0 landfill waste. 0. And the economics have flipped so completely that the fluff is no longer a disposal cost. It is a feedstock. The same material that shredder operators spent 40 years paying to bury is now a revenue stream. The last 5% became the first 5% of a new supply chain. This is the arc of 100 years. The man with the horse-drawn cart pulled a car apart for a few dollars of scrap. The shredder chewed 300 cars a day and buried a quarter of it in the ground. The robot learned to see every bolt and every battery, pushing recovery to 95%. And a quiet Austrian engineer finished the job with a reactor that turns the final residue back into fuel, back into rubber, back into road. The circle that Rudolf Diesel and Henry Ford dreamed about, the idea that nothing ever truly becomes waste, is now closed. Not by a government mandate. Not by a corporate sustainability report. By the same force that drove the first wrecker into a muddy lot in the 1920s. Someone saw a mountain of discarded things and asked what it was actually worth. That question, what is this actually worth, is the engine that drove every single leap across this 100-year timeline. From the wrecker with his hammer, to the shredder, to the robotic arm, to the reactor that turns fluff back into fuel. It is the oldest question in capitalism and the newest question in sustainability, and it turns out they have the same answer. The electric vehicle and the wind turbine blade will not be recycled by the machines of the 20th century. They will be unmade by someone smarter tomorrow. And for the first time since a Model T broke an axle and got dragged into a muddy lot, the blueprint for that future is not in a government report. It is already running on the fumes of its own garbage in a quiet plant south of Vienna. If this made sense to you, hit subscribe and like. And if you are someone who sees opportunity where others see a problem, check the first pinned comment. There is a link there I think you will want to see.